Hello, today's video is going to be on differentiation and the basics of differentiation. Too often you'll learn a concept in maths and dive straight into solving questions on it without really understanding what this concept is, what is the idea behind what the math is trying to actually achieve. So this video is going to be mainly explaining the theory behind what differentiation is, which is really important to know when you get into especially more complex situations later. Differentiation is part of calculus. And there are two main parts of calculus: differentiation, which I'll talk about today, and integration. That is pretty much all there is to calculus. There are different parts of each of these that spring off each other. Then you may have to do things which involve both of them or just one of them. However, in the end, it all boils down to just differentiation and integration pretty much all of the time. Differentiation, which is what we're going to focus on today, is the function that takes a normal equation, y equals something, and gives you another equation, which you can put your values for x into, and giving you the gradient at that point. So you basically turn a normal equation into the gradient function of that equation. So in this situation, we're going to do very simply y equals x. The graph looks like that. There we are, y equals x. When you differentiate, you change from the form of y equals something to the form dy dx equals something. This is something that confused me a lot when I started doing it, thinking, well, what does this dy dx actually mean? What's this notation? Why is it like that? The reason for that is if you want to calculate the gradient of a line like this, you would look at the change in y over the change in x. And that would give you, for constant gradients, that gives you the answer. And therefore, if you look at and compare these two notations, they're very similar. So that makes sense for effectively changing y over changing x. For this situation, don't worry about knowing how to differentiate at the moment. I'll tell you that the answer is 1. And as if you compare it to the graph, the gradient is 1. In another example, so in this one, so the gradient function of y equals x is dy dx equals 1. If you look at an example of y equals x squared, and draw that here, x, y, then when you differentiate it, and you go to the dy dx form, which differentiator form, it differentiates to 2x. Don't worry about knowing how to do this at the moment. That's for later on. It's just explaining sort of the theory of how it works. So, if you plot here the just the values of x along this line, you have -2, -1, 0, 1, 2. That's just the corresponding values of x along here. And then values of 2x, which is the gradient at that point. So effectively substituting in this into this equation, you have -4, -2, 0, 2, and 4. So when you look at this graph and think, well, at 2, the gradient's 4. At 1, the gradient's 2, because it's positive gradient in this direction. In this direction, there's a negative gradient. So at -1, it's a gradient of -2, sorry. And at a gradient of -2 is a gradient of -4 at this point. And then obviously over here, where it crosses the y-axis, there is a gradient of 0. So the differentiation has allowed you to find an equation, the gradient function, that means you could put in any value of x, and it would give you the gradient at that point, which is very useful. Later on, you'll find that it can be slightly more complex, and differentiation can be used for other tasks as well, because it always boils down to the same idea of finding the equation for the gradient of the line. Hopefully that gives you a better understanding of what differentiation is and the theory behind it, and also what is the point of differentiation itself. Thank you for watching my video, and I hope it helped. Thank you.